Are we recording yet?
Yes, we are.
Oh, awesome. Thank you. I'd like to thank everyone who's joining us today. Welcome to today's CNCF webinar, Kubernetes Storage in Action. I'm Jeffrey Sika, a senior software engineer at Red Hat and a cloud native ambassador. I'll be moderating today's webinar. We would like to welcome our presenter today, Sheng Yang, software architect at Rancher Labs. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a QA button at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. If there are a couple poignant questions during the presentation, Sheng said that we can feel free to grab him and then try and answer them while it's relevant. This is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful to all of your fellow participants and presenters. The recording and slides will be posted later today on the CNCF webinar page. We'll provide a link to that, but it's cncf.io/webinars. With that, I'll hang it over to Sheng to kick off today's presentation. Sheng?
Hi, so welcome everyone. So this is Sheng Yang. I'm from Rancher Labs, and today our topic is Kubernetes Storage in Action. So, all right. So first, a little bit about myself. I've been with Rancher Labs since 2015, and before that, I also worked at Intel for the KVM kernel development and at Citrix and Cloud.com for the cloud stack development. So you can find me using Yasker at GitHub, Twitter, and Medium. And also, if necessary, you can send me email for any questions you have in the session to sheng.yang@rancher.com. So I will glad to answer them. So with that, let's get started. So the reason we are having this webinar is the concept of the persistent storage in the Kubernetes is a little bit always a little bit confusing. And from what I heard from the end users and many talk I had in doing the multiple KubeCons, there's people always asking about many difference between the like PV, PVC, other read-write ones, read and many, those kind of concepts in Kubernetes. So that's one thing we want to talk about today is go through the persistent storage concept in the Kubernetes in one go, and I will try to explain them as clear as possible. And I will make sure that you are going to get a concrete understanding of the Kubernetes storage concept after this webinar. And the second part of this webinar is I'm going to show you how to use persistent storage in Kubernetes doing a live demo. And for the live demo purpose, we are going to use Rancher and Longhorn, which are two open source projects and in the Kubernetes area. And you are feel free to download them and try them by yourselves. So the first thing I want to talk about is like just list the concept of persistent storage in the Kubernetes. The most common one you might have heard about is persistent volume and persistent volume claim. So in short, what the persistent volume is a piece of storage can be used for the Kubernetes like Kubernetes pod. And the persistent volume claim is a request for the persistent volume, in short PV. And the one common misconception about persistent volume and persistent volume claim is you probably think like, okay, persistent volume is like a storage pool and persistent volume claim is going to carve in one part of it. In fact, that's not true. So in Kubernetes, persistent volume and persistent volume claim is always going to be one-to-one binding relationship. So one persistent volume can only be used by the one persistent volume claim, and the one persistent volume claim, of course, are going to be bound by the one persistent volume as well. I will explain more of that later. So the next concept you're going to likely encounter is the storage class. So the storage class is essentially a connection of persistent volumes. And when the storage class work with the provisioner, and you can have a dynamic created persistent volume instead of static allocated persistent volume by other means. So I will go into more detail on that later as well. So the last concept you're probably going to encounter is just simply called volume. But in the for the volume inside Kubernetes, in fact, it's just referred to the storage, whatever storage used by the pod. So it's not necessarily persistent. So if the volume is pointing to a persistent volume claim, then we will assume that this volume is most likely to be persistent storage. But if the volume is using something like host path or empty directory, and those are not really treated as persistent. So here, in fact, the persistent storage in Kubernetes has evolved a bit since the incubation of Kubernetes. So the one major event in this involvement is the storage class. So before, storage class was introduced in Kubernetes, I think it's introduced about in the 1.5, 1.6, around that time. And before that, every time, what's the model of persistent storage is that the storage admin have to allocate persistent volume first, and then there will be a bunch of persistent volume claim try to bound it into the persistent volume. For example, now we have create a multiple pods, and the pods have volume, and the volume going to pointer to a persistent volume claim. And in this case, Kubernetes is going to try to match the persistent volume claim to any existing persistent volume through the parameter like the capacity, and the performance, and using those parameters to find the PV that matched the requirement of PVC. So once Kubernetes found the required PV, the PV met the requirement of PVC, they're going to bound them. And you can see that the PV status will become bounded, and the PVC will start pointing to that PV, and then the pod can start using the PV as a volume inside the pod. So this model have a few issues. The first one is like, since the PVC only specified this like some spec like the size of the PV, the storage what you want, the PV can be over satisfied, like just say the spec of the PV can be better than the PVC wants. For example, I only ask a PVC for like 1 GB of volume, but there's no existing free PV, which that with 1 GB of free space, the smallest PV I have might be 100 GB. So even in this case, Kubernetes was still going to bind that 100 GB PV into the PVC, which results in the waste of space. Another issue with this model is that those PVs are statically created by the storage admin beforehand. So in order for this model to work well, the storage admin have to be involved in the older process that using the storage, the persistent storage. And essentially the storage admin have to predict that how many PVs and what's the PV size going to be used by the PVC, which is next to impossible. So this this model provides very good like permission and the request isolation, but it's not really particular flexible when we want to have a lot of pod and volumes with a lot of PV and PVCs, since storage admin need to be manually involved in every step of this allocation. So after Kubernetes Kubernetes community realized this problem, they introduced the concept of the storage class and the provisioner. So in the new model, the storage class with provisioner is basically operate as in the role of the storage admin, but it can done the work automatically. So in this case, we still have 4 PVCs, and the 4 PVC had different requirements, and the pod we're going to create as same as before, the volume pointed to the PVC, and in this case, PVC we are going to see, okay, is there any existing PV can meet my requirements? If not, PVC we're going to talk with the storage class with the provisioner, and the provisioner we are going to provision new PVs according to the spec requested by the PVC. So those new PVs will going to match the spec of PVC 100%. For example, if you are going to ask for 1 GB of volume, the provisioner will provision you most likely the 1 GB of volume as with like say based on SSD, and the provisioner will do that as well. So in this case, you are going to have a strictly matched spec between the PV and the PVC. And also you don't need to worry about get the storage admin manually involved in any volume creation process. So of course, after the PV was created automatically by the storage class and the provisioner, the PVC will going to bond with the PV, and the pod can start use the volume again. Sorry. So another, so in this case, you can see that with the introduce of the storage class, the allocation of the volume and the persistent volume become more flexible. And you can, and also there's one thing about the storage class is as you notice that I mentioned here that storage class will be with the provisioner to automatically provision the new PVs, but also you can use storage class without the provisioner. So that storage class will essentially become a connection of the PV. So in this case, if you specify the certain storage class, and if there are multiple PVs with that storage class, then PVC will going to only bond into one of the PVs with the same storage class as the PVC specified. So that's also a way for you to allocate existing PVs into one group and make sure that PVC is going to grab some PVs and bond to them within the group. But in the most common cases, the storage class is working with the provisioner to provide the dynamic provision feature to the PVCs. So that's about PV, PVC, and the storage class and provisioner. The next concept we're going to talk about is read-write once and the read-write many. So those are the access mode of the PV can have in the Kubernetes. So the read-write once means that you can only, the storage can only be read-write on a single node at any given time. And the read-write many means that you can read-write on multiple nodes at the same time. So why it caused the difference? In fact, the difference is caused by how the storage was the internal functionality of the storage. The read-write once type storage is most likely the high performance block storage like AWS EBS, Azure Disk, Google Persistent Disk, Sapphire RBD, and Longhorn. So the block device is, since the block device can only be attached in the one node, and also you cannot modify the block device contents without the file system knowing. So the block device is most likely unable to be read-write at a single node. But in other cases, you can probably read only using read-only manning for the block device as well. Like you can mount this block device on the multiple node. As long as you are not write anything to it, you can still read from it. So the read-write many type storage is most likely distributed file system. So like AWS EFS, NFS, LastFS, and StatefulSet. So the read-write many, the type of storage is on the file system level. So any change you done on the multiple node will be made aware to the file system, and the file system are going to have a protocol to deal with that. So you are able to use the this type of storage across the different node. So, but on the contrary, sometimes you because it's involved in more locking and the file system level protocol, the performance of the distributed file system is probably not as good as the dedicated block device. So, talking about the read-write once, read-write many type of access mode, we need to also think about how to use them. So there's two common ways of using persistent volume in the Kubernetes. One is using deployment, another one is using StatefulSet. So of course, everybody is probably going to most familiar with this deployment. And the deployment has a property that the pods in the one deployment is going to share the same volume. and the deployment can be, as you know, the deployment can be spread across different pods. So so the storage for the deployment have to meet the requirement that no matter which node the pod is running, the storage must be accessible on that node. So the deployment is more suitable for the read-write mining type of storage. On the other hand, because some workload can scale really well horizontally, so we also have a concept of the StatefulSet in the Kubernetes. So each pod in the one StatefulSet can have one volume. That is because we have a new concept here called volume claim template. The volume claim template is essentially automatically provision new PVs and with the PVC specification, and they are going to use that newly created PVC for each pod in the StatefulSet. So in this case, if you have workload can scale horizontally really well, you can have a StatefulSet for that workload and using the high performance read-write once type of storage like block device with your StatefulSet and with your workload. All right, so we have so I'm the maintainer on the Longhorn project, and the Longhorn is a CNCF sandbox project, and it's a distributed block storage software for Kubernetes. And Longhorn is 100% open source. So Longhorn is in the catalog at the read-write once type of storage, as I mentioned before, with the EBS and others. So what we do with Longhorn is we want it to easily provide persistent storage support to any Kubernetes cluster. So you can find more details about Longhorn at longhorn.io. And I'm going to demonstrate how to use Longhorn and Rancher and Kubernetes to operate on persistent storage later. Just a little bit update on what's the latest status of Longhorn. So the latest release is 0.7 release, and as I said before, Longhorn is enterprise-grade distributed block storage software for Kubernetes, and we support volume snapshot inside the cluster, and also you can back up and restore volume from outside the cluster like S3 or NFS server. We also support storage tag for the node and the disk selection. For example, if you have some data that doesn't require very fast access, faster bandwidth, you can have the label for example, SSD and NVMe on one side, and the label for the spinning disk on the other side. So you can choose the different speed of your disk using the storage tag. Longhorn also support cross-cluster disaster recovery volume with defined RTO and RPO. So RTO here is a recovery time objective, and RPO is a recovery point objective. So those two parameters define how soon and how soon you can recover your volume in your backup cluster, and what's the point of data is going to be recovered in your backup cluster. Longhorn also support live upgrade of software without impacting the running volumes, and we also have intuitive UI, which is the one first thing many users like about Longhorn. And of course, Longhorn is right on top of Kubernetes and using Kubernetes controller pattern. So we support one-click installation, and it's very easy to install. I will demonstrate that later. So of course, we have more feature coming, and let's start the demo. All right, so before our demo, do we have any questions?
None have popped up so far.
Okay, good. Okay, so here what you see is the UI from Rancher. So everybody see the UI?
Yep, you're looking good.
Okay, so as you may know, the Rancher is the Kubernetes management platform. It's also 100% open source, and the Rancher can manage multiple clusters, multiple Kubernetes clusters from different provider, no matter it's on premises or in the cloud. As you see here, this is the 3 of clusters is in the DigitalOcean, and 1 cluster is Linode. So let's go dive into the demo. So when you click into the demo dashboard, cluster dashboard, you're going to see the CPU and memory usage and the pod stats, and you can see that this cluster is with 3 nodes, and which help on the CPU, and what's the version of the Kubernetes and the Docker on top of node. So the storage type here, you can see that we don't have any persistent storage, persistent volume or storage class created. So we are going to now start by installing Longhorn to add persistent storage feature to this cluster. So to install Longhorn is very easy. Just go to the project and click app and click launch, and find Longhorn in the Rancher catalog. And Longhorn, of course, is also available in storing from the YAML or from the Helm chart. And in the backend, this is using the Helm chart as well. So I don't need to change everything. I just click launch. Well, when we are installing Longhorn, let's go back to the dashboard for the demo cluster. And in fact, we can launch kubectl here. And it's where you can just run every command using kubectl. Oh, nothing is on default, but yeah. So now the Longhorn is installing in the Longhorn system namespace, and you can see the things that are running here. And of course, you can see the real-time status of all the pod in the workload here. So it is installing it right now. Haven't finished yet, I think. Let's see if I can access the UI yet. Oh, okay. In fact, the UI is ready now. So in the Longhorn dashboard, you can see what the current status, like how many volumes you have, what's the health of them, and how many storage you are available for you to create new volumes, and how many nodes is here. On the node page, you can configure the Longhorn are going to use the space on the disk to back in the Longhorn volumes. And of course, we don't have any volume right now. And Longhorn also, as I mentioned before, Longhorn also support backing up to others. And let me set the backup target first. So that is the setting to S3, and you can see that we already have some backup here. So let's dive into the persistent volume and start using it. I think I need to refresh this. Oh, yes. Okay. So the first thing I want to do is I want to start a WordPress application, which is using Helm chart and using Kubernetes, using Longhorn persistent volume. So this is a standard WordPress Helm chart. And you can select WordPress persistent volume enabled and using Longhorn as storage class. And also, you know that WordPress Helm chart has 2 parts. One is WordPress itself, another one is the database, MariaDB. So we want to use the storage class for MariaDB as well. So let's click launch here. And from here, we should be able to see that there are 2 volumes created. So Longhorn is communicating with Kubernetes using the CLI interface, and the volumes are being attached. And the same to healthy. And you can also see from the Longhorn UI that this volume is used by the MariaDB, another volume is used by the WordPress itself. And you can click to see the details. So, okay, so let's go and see how the persistent volume, let's see the persistent volume and the storage class. So in the storage tab now, you can see that we have 2 persistent volume and the states will be bound. And the storage class, of course, when you install Longhorn, we are going to create a new storage class with dynamic provisioning feature. And you will see here in the storage class tab. You can also see that using the kube control. And in short, because in Rancher we type kube control so many times, so we normally just shorten to use a k. So you can just do k get PV, and you see to persistent volume is has been created, and you see use k get a storage class. Yeah, you can see the Longhorn is there. So we can take a look into deep about the PVs here and see what it have. So this PV has been associated with the, let me see, okay. You can see that this PV is using the CSS driver and using the Longhorn, and we using file system as ext4 as our default, and some other parameters provided by Longhorn. And also you can see that this PV contains the size of the volume we want, which is in fact determined by the PVC. This is 10 gigabytes. And this PVC, and also this PV contains the info to referring to the PVC is using the PV, like this PV is using by the PVC name in the name WordPress, in the namespace WordPress. So let's take a look at that PVC as well. So now we have see this, we switch to the WordPress namespace and take a look at the PVC. And previously we see this volume, you see this volume name here. In fact, this is the PV which associated with this PVC named WordPress. We can take more into, we can look into that more. You can see this PVC was created with access mode rate write once, which is suitable for Longhorn. And also they ask a request as resource as a storage 10 gig and the storage class as Longhorn. So that is how this PVC able to find Longhorn storage system and able to create a new PV to meet this demand. And you can see the volume mode is file system. Another volume mode available in the newer Kubernetes release is a raw block device. So the volume name will be this PVC-6EA something. This is the PV name we mentioned before. So let's take a look at the storage class. So this is the storage class, how storage class looks like. The most important parameter here is you have to specify the provisioner if you want to do dynamic provision for the storage class. And another one is reclaim policy, which means that what will happen if the PV has been unbounded for the PVC. And if you, the reclaim policy is what will happen if the PV was going to be removed, it's going to be deleted out. In this case, another one is recycled. And also there's was special annotation here. So by default, default storage class means that if you are creating a PV without specifying the storage class, this one will be, this storage class will be used as in default. So let's go back and take a look at the pod is currently running. See some questions. Okay, so yeah, so I see some questions here. So I can.
I wasn't sure if you wanted to answer them at the end because some of them weren't necessarily related to what you were talking about.
Okay. All right.
If you want, we can tackle a couple of them right now.
Okay, so yeah, so first question I saw from Rush is that is it possible to use Longhorn in a deployment? It's possible for Longhorn to use in the deployment, but you are not able to scale beyond one node since it's read-write once, and Longhorn cannot be run in the read-write many mode. The next question is coming from Reno. So the question is, what will be the default data location for Longhorn, or how can I allocate space that Longhorn can use? So the default data location will be at /var_lib rancher longhorn, and we are changing that to /var_lib longhorn. So in order to allocate space for longhorn, you can just mount a new have some block device on the node and mount it, format it in ext4 or XFS, and mount it on some directory on the node and tell Longhorn about it. So we can see it from here. In the Longhorn UI, so you have the node here, and you can edit this node, and you can add a disk, which put in a different path here, and then you can have another disk using prepared for Longhorn. So also you see that the default path is var_lib rancher longhorn at this release. So the next question is, well, does Longhorn provision the actual underlying storage? Does this using EBS automatically deploying AWS? The answer is no. We currently just depends on how the users the disk has been mounted on the node. So in order to use EBS, you need to create a EBS volume, attach it to the VM, and format and mount it on the node. Then you just supply the path to the Longhorn like that. But we are also considering automatic provision new block devices if you're using some cloud provider solutions. So what's the difference between the PV get deleted and the recycled? So the PV get deleted is basically means, if I remember correctly, is that when the PVC is get deleted, PV is going to get deleted along with it. And if the reclaim policy is recycled, if the PVC was deleted, the PV will not get deleted automatically. It will going to be just there, remain as unbounded, but the content will still be there, and the next PVC can pick it up. In fact, it's not really 100% safe. You do this way because you know that the data can be reused. So can you compare Longhorn with Ceph? So one of the motivation we develop Longhorn is because we kind of think Ceph is too complicated. And we heard because our previous experience is like with CloudStack, which is like competitive OpenStack. So there are some user stories about how hard the Ceph is, how hard to operate, and those. So the Longhorn itself is much simpler. So we only use replicas to store the data. We're not doing striping, and we try to keep the code as simple as possible, and also we also have the built-in backup mechanism compared to Ceph. So Ceph doesn't have built-in backup mechanism. And the Ceph itself is not really cloud native because Ceph was built before the Kubernetes was born. And of course, as you know, that the project Rook is helping Ceph to become cloud native. But that is, to our understanding, of course, there will be another layer on top of Ceph. So it's going to be introduced more more complexity factors to the operation. So where do you specify the volume mode as file system while deploying the WordPress app? The volume mode as file system is the kind of default setting for provisioners. So unless you specify the volume mode to be the raw block device, they're going to by default file system. And also the volume mode is also determined in the request of the PVC, which is in the WordPress chart. And the WordPress charts already defined it. Okay, so we're already using Rancher. We can expect Longhorn to be product grade. So Longhorn to be, we are targeting Q2 this year for the Longhorn to reach GA. So that's, well, at that time, we're going to support Longhorn, and the claim is to be the production grade. And now Longhorn is still in the beta release. So can you elaborate how it works on the multi-cluster configuration and RPO, RTO limits? Well, that's a topic is probably too deep for this webinar. So I can briefly talk about that. So in the multi-cluster configuration, it's running as a master backup-like setup, and we are going to constantly pull from the backup target to the backup store for the latest data that's shipping from the master cluster. So the backup cluster going to get a refresh. You can define the refresh every how long you want. And the RPO, RTO limitation, the RPO limitation depends on how often you are going to back up your volume in the master cluster. The RTO limitation is also determined by how fast you can transfer, activate the volume and put into the workload. I would say that RTO limitation will be pretty optimal, and RPO will depend on your setup. Oh, sorry, I think I just wrongly clicked. So, all right, so that's all the questions we have right now. Let's go back to the demo. Okay, so this one. Okay, so as you can see right now, the WordPress is up, and you can see it's functioning well. Everything seems working, and you can add new post. Yes. Okay, everything seems fine. So we can dive deep into how WordPress is using the pod, and you can click here. We can see the volume. One is, of course, configure map. Another one is volume claim template called data. And in fact, we probably see that better from the kube control. Let's do that. So as you can see right now, the WordPress namespace has two pods. We can see the MariaDB one. Oh, pod. Okay, so you can see here, this one data volume is using the claim data WordPress -MariaDB-1. So, but how it got here? So that is because we have the WordPress is using StatefulSet for MariaDB. So as you can see here, so this StatefulSet, the first part you will see that is just typical spec for for the container, right? But one part is StatefulSet only feature is this volume claim template. So the volume claim template defines that what's the how to create a new PVC automatically if I'm going to scale the database. We'll say that we are going to have those labeled, and also the PVC is going to create it must be read-write once, and the resource must be 8 GB, and the storage class name is Longhorn, and the volume mode is file system. So this is specified in the volume claim template inside the WordPress chart. So in fact, I can just scale up. I can scale up the database, and you will see what's going to happen. In fact, I haven't tried this before. Yeah, I hope it won't fail. Okay, so a new volume has been provisioned automatically. You can see the third one, and you're going to get attached. And it's going to be used by the new MariaDB pod. Let's see here. Wasn't up yet. Okay, so container started. And as you see, you can also see the log from the rancher as well. Okay, when will you become ready? Well, I'm a little bit regretting. I'm not sure if you actually tried this. Oh, okay. All right. Now it's fine. Okay, so at the same time, as you can see there, new volume has been created by for the MariaDB1 in Longhorn because MariaDB is using volume claim template to create new volumes. And also, in fact, in the Longhorn UI, you can click into each volume and see what's the detailed information about it. So here, on the right side, you will see that you have 3 replicas running on different nodes and which path you are using. And the tooltip here shows exactly place that Longhorn stored your data. So since we're doing just 100% replication, so you have, as long as you have the data on this path, for example, if you have node crash or Kubernetes cluster crash, as long as you have hard drive and still contains this data, it's still possible. We can still recover from that crash and still get your data back. So that is the one of the fail-safe mechanism designed in Longhorn. So on the left side, you can see that the volume current is attached and healthy, and you have attached a node to the Longhorn demo 2, and this is the block device on the Longhorn demo 2 that's exposed by the Longhorn system. The size and the actual size Longhorn take on the space, since we're doing the same provisioning, the actual size is only 200 megabytes, and most of them, in fact, is just the file system and the engine and some other parameters. So down here, we have a snapshot screen, and you can take a snapshot. And just remember that snapshot is made within the cluster, and also you can create a backup, and you can add a label to the backup if you want. And you can see that it's copying to the backup store right now. Okay, that's quick. So recurring snapshot and backup schedule. So we have a built-in mechanism for you to create backup and the snapshot on the schedule for like daily or weekly or monthly upgrade. So I'm going, monthly backup. So that is why we want to ensure that your data always has a copy outside the cluster. So when you lost your whole cluster, you are not going to lose your whole data. So here, just for testing purpose, I'm going to do a backup every minute and click save. And this should be kicking in about minutes. So let's go back to the, okay, so let me see if I have any questions. Okay, so yeah, so I saw the questions about access mode and the use case for each of them. So the basically the things is, if you want to use the basic concept is, if you have a workload that can scale horizontally, like a database, most database can scale horizontally and doing the shard. And when you have that kind of workload, you better use the read-write once block device with the StatefulSet, so you can easily have a different storage for different block storage, different storage for the different parts across a different node. But sorry. So, but if you don't have that, but if you have the workload that's going to scale, but they are planning to share the same storage, they can have something like internal logs, and they have multiple instances able to share the same storage, and you can use read-write manning type of storage. And in that case, you can use deployment and read-write manning type of storage to scale your workload. And in that case, that all this workload, all these parts were going to share the same volume. So you can see that there can be some bottleneck on the performance, but if your workload only allow that, there will be your way.
So there was one other question that was in the chat, not actually in the Q&A.
Yeah.
Do you want me to read that off to you?
Sure.
If a node needs maintenance and has to be upgraded and all the containers need to be migrated, can you describe the process when you already have a bound PV that is local storage? This can happen with local storage and PMEM backed volumes.
Okay, so if you have the workload, and if you're going to if you have the node, you have to most likely you have to drain it, and there the pod will be moved. Since if you are using deployment of StatefulSet, they are going to be less than ideal replicas on that node on the host scale. So the pod will be moved into other node, and but if you are using local storage, in fact, the local storage, I need some clarification here. If you mean by local storage is that storage is bound on that node, like another project I have, just local path provisioner. In that case, that your storage is always bound by that node, so you cannot really move that storage. So the other pod will not going to have the storage available to it when startup. So in that case, you are going to lose one replica. But if you have some system like Longhorn, that storage will be migrated into another node, because that the Longhorn or some other storage system like Ceph are going to have a replica on the older nodes. So they can connect back to their replicas or their data through a different node, and then continue functioning from there. All right. So that's all from my presentation. Let's go back to, that's all for my demo. Let's go back to our presentation. I think I have another slide. All right. So just one last thing mentioned about Longhorn. So in the next release, 0.8 release, we're going to have volume resizing, topology support, and live upgrade v2 coming. So the volume resizing is a feature many users has been requested. So now we support volume resizing from the Kubernetes 1.16 release, since that is the first time the volume resizing become beta in the Kubernetes. The Kubernetes topology support in a previous known as a failure domain is a new feature added in the Kubernetes to help deal with the replication in the one region, but in the different availability zone. Like the case that if you are using EKS, you are going to have a region-wise control plane by default, but your node can fall into different AZs. And also the one thing about AWS is that your EBS volume is in fact bound to the AZ. It cannot be migrated across the AZ. So if you have one region down, one availability zone down, this kind of cases, you are going to lose that data in that AZ. So what we add is on top of the EBS, you can use Longhorn to provide across availability zone support using this new topology support we added in 0.8 release. So after that, we don't expect many major changes, and we are targeting Q2 2020 for the Longhorn 1.0 GA release. And you can follow up the latest update at github.longhorn.com/Longhorn milestones. And also for the Longhorn related content of Longhorn related discussion, you're welcome to join the CNCF Longhorn channel or the Rancher user Longhorn channel. So we are migrating from the Rancher user channel to the CNCF channel, since we have become the CNCF sandbox project. So that's all for my presentation. So any other questions?
Yeah, if there are any other questions, we do have time for a few more. You can just click the Q&A tab at the bottom of your screen. But if there are no other questions in the next minute or so, I think we'll wrap it up.
All right.
All right. Thanks, Sheng, for a great presentation.
Thank you.
That's all the time we have for today. Thank you for joining us. This webinar recording and slides will be online later today. We are looking forward to seeing you at a future CNCF webinar, and please have a great day.
Thank you.